In this final video on graphing point slope and quadratic equations, I want to take a look at going from the point slope form to the economic form of an equation. So this is our basic form, and so recall that this is where we have y being equal to some a plus m of x. Well, this is the point slope form, such that a is equal to 3 1/3 and m is equal to 1/3. Now, if this was the quadratic equation, which in fact this is a quadratic equation, we want to think of it as y is being equal to a times x squared plus b times x plus c. So not a and m, but a, b, and c. And unfortunately, a in the point slope is not a in the quadratic. In this case, for our equation that we see here, we have 0 times x squared plus 1/3 times x plus 3 1/3, or a being equal to 0, b being equal to 1/3, and c being equal to 3 1/3. So it's a little bit confusing. Try not to let yourself get confused as you're going from the point slope to the quadratic equation and getting a little bit confused with the different variable iterations in the convention in which we think of these equations. So with that, how do we turn this into an economic form? We very often see an economic form is going to be something like quantity supplied is equal to, say, -10 plus 3p, such that we've got our Cartesian coordinate structured in price and quantity. So we have a p variable that is our y and a q variable that is our x. So what we've really done here is we've created this economic form. This is really x is equal to some, what I will say is some constant plus some slope times price, or times y. So it's really, we're looking at the same kinds of issues and variables. We're just looking at them and calling them p and q. So p and q. So how do we go from y equals 3 1/3 plus 1/3 x to q equals something plus something times p? Well, in this case, we're going to simply normalize the equation on q rather than having it normalized on p. Right now, the equation we're looking at is really p is equal to 3 1/3 plus 1/3 q. In this case, we're going to call it qs, or quantity supply. So let's look at normalizing this. And all normalizing means is we're going to solve for the other variable in this case. Right now, we're normalized on p. We want to be normalized on q. So to do that, let's go ahead and rearrange the equation. And we'll say 1/3 qs is equal to p minus 3 1/3. All we did was we subtracted 3 1/3 from each side of the equation, and then we flipped the equation. Well, to isolate qs, or to normalize, solve for q, we're going to multiply each side of the equation by 3. It's going to leave us qs is equal to 3p minus 10, or if we rearrange 3p and -10, we are qs is equal to -10 plus 3p, which is the same equation I put up over here a few minutes ago. Well, let's go ahead and put this into a graphic form that we can use as economists. So in this case, we know we're thinking about our Cartesian coordinate, but before we do that, let's find some points that we can rely on. So we're first going to find our x and y intercepts. So for qf, if p equals 0, then I have qs is equal to -10 plus 3 times 0, or it's equal to -10. And if qs is equal to 0, then I have 0 is equal to -10 plus 3p, or 3p is equal to 10, or p is equal to 3 1/3. If I'm looking then instead at QD, so finding the intercepts, because that's what I'm looking for right now, if p is equal to 0, then I have QD is equal to 15 minus 2 times 0, using the QD is equal to 15 minus 2p, or it's equal to 15. And if I have QD is equal to 0, that's 0 being equal to 15 minus 2p, or 2p is equal to 15, or p is equal to 7 1/2. So this simply gives me a couple of points in my Cartesian coordinate, a couple of points on each axis, P and Q, for these curves. So let's think about where these live. By the way, P is price, Q is quantity, and when you're thinking about finance or economics, you always put the currency denominated variable on the y-axis and the quantity denominated variable on the x-axis. That's consistent construction and discipline within economics and finance. The price or currency denominated variable on the y-axis, the quantity denominated variable on the x-axis. So what are these curves going to look like? Well, without having all the information I might like, I think that my demand curve is going to have QD at 15. It's out here at 15, and is going to have P at 7.5. So let's say 7.5 is up here, such that I have a demand curve that looks like this, and I'm calling that QD. As I now think about my supply curve, I know that I have a P at 3 1/3, and I have a QS or Q at -10. So that's back here, -10. And this would be our QS. What I don't know is the value for this intercept. I don't know what that is, and that value is going to be thought of as P star and Q star, or some market clearing, market equilibrating values of price and quantity, or the value of price when quantity demand and quantity supplied, quantity demand and quantity supplied are the same thing. So how do I find that? I find that by setting these two equations equal to one another. I know that at this point, right there, quantity demanded and quantity supplied are the same. So let me think about how I can find that point. Well, I'm going to set quantity supplied equal to quantity demanded. So that's going to be -10 plus 3p is equal to 15 minus 2p. Okay, now I can just rearrange this and solve for p, or I can say that I've got 5p is equal to 25, or p is equal to 5. Okay, well that's my P star actually. So I know again that at this point, I know that some P gives me both quantity demand and quantity supplied. So to find the value, I can put this value for P or P star into either of these equations. I can say QD star is equal to 15 minus 2 times 5, or it's equal to, looks like 5. 15 minus 10. And I can say that QS star is equal to -10 plus 3 times 5. And that once again equals 5. So QS and QD are the same thing. We see that here. QS and QD would be the same at some price. And that is called P star, or Q star, excuse me. Well, as I graph this then in economic terms, I'll come back. I'm just going to primarily focus on positive space at the moment. And I'll use the intercepts that I had from before. I know I've got a supply curve. We noted it here. That's coming through like this at -10 and at 3 1/3. I've got a demand curve is going to come through something like this. Such here is 7 and 1/2, and here is 15. And now I know the values here. I know that P star was equal to 5, and Q star was equal again to 5. I know that I have gone from the point slope form to an economic form. I now know that I've applied the same principles that we talked about for the point slope form to the economic form, and I've graphed each of those equations, and I've gone ahead and isolated this value at which the quantity supplied equation and quantity demand equation are equal to the same thing. You'll find in your business and economic courses you'll do that over and over and over again.